Now I have some good news. The way we access tuple elements is the same as the way we access list elements. So this video should be more of a refresher, so let's remind ourselves how we access elements. Firstly, we can use indexing. So we can use the index operator, which is square brackets, to access an item in a tuple. So here I've created a tuple with 1, 2, 3, 4, 5 as separate elements. I then have a list element with the integers 6, 7 and 8, and then I have a tuple element with the numbers 9, 10 and 11. So if I wanted to access the number 5 in this tuple, I could put my underscore tuple, and I could follow this with a set of square brackets. Now to access number 5, I would need to put in index 4, seeing as indexing starts from 0. When I then run this code, we get 5 returned. Now if we count the number of elements in this tuple, we have 7 in total. 5 integers at the start, 1 list element and 1 tuple element. So if I was to try to access my underscore tuple and provide an index which is out of range, i.e. if we try to access the element at index 7, you can see we run into an index error, telling us that the tuple index is out of range. So therefore when you're trying to access an element, make sure that the index is in range, otherwise you'll run into an index error. Also remember that the index must be an integer, so we can't use floats or other types. So if we put my underscore tuple and inside square brackets we put 2.5, this will bring back a type error stating that the tuple indices must be integers or slices, not floating point numbers. Okay, so moving on. Can you remember what we'd need to put in order to access the number 10? We can use nested indexing. So here, the number 10 resides in the last element of the tuple, which in itself is a nested tuple. So if we type my underscore tuple and inside square brackets we put index 6, we return the full tuple, i.e. 9, 10 and 11. Now if I chain another indexing operation to this index operation and put square brackets 1, seeing as 10 is the second element within this tuple, you can see we obtain the number 10. So we're able to access nested structures inside of a tuple by using nested indexing, just like we would if we were accessing nested lists. Now if you remember, we can also use negative indexing. So let's say we wanted to access the number 11. How do we go about doing this? Well, seeing as the nested tuple is the last element in our main tuple, we can put my underscore tuple and inside square brackets we could put -1. Now -1 refers to the last item, and -2 would refer to the second last item, and so on. So if we now wanted to access number 11, we could chain an indexing operation where we once again put -1. So we take the last element in the main tuple, and then we take the last element in the nested tuple. When we run the code, we bring back the number 11. Now if you also remember, we can slice lists by passing in a starting index and an ending index. So if we were to try to access the numbers 1, 2 and 3, we can have my underscore tuple, and inside square brackets we can put the starting element, which we know is index 0, and we can then put a colon. We then want to go up to the third element, so we'd place index 3, seeing as the third element is index 2, and we go up to, but not including, the end index. When we run this, we get the values 1, 2 and 3. Now inside this operation, if 0 is our first index, we can actually remove the reference to the starting value and simply put a colon. This will simply mean from the start of the sequence. And if we were to remove the end index value within the slicing operation, this will go up to the very end. So if we were to put my underscore tuple and inside square brackets, we simply put a colon. When we run this, we get all the elements from 1 all the way up to the last item in the tuple, which is that nested tuple. With slicing operations as well, we can use negative indexing. So if we wanted to go from the third item from the end all the way to the end, we could put my_tuple, and then inside square brackets, if we put -3, which we know would be the integer 5, and then we put a colon, this will grab the element 5, the list with 6, 7 and 8, and the tuple with 9, 10 and 11. So hopefully this was a bit of a refresher as to how we can use slicing and indexing on tuples. It takes the exact same form as lists, so it should be something you're comfortable with already. Now so far we've seen a lot of similarities between tuples and lists, but unlike lists, tuples are immutable. Now that means that elements of a tuple cannot be changed once they've been assigned, whereas we can change elements of a list. So for example, let's take the tuple that we created in the last video. So if we access the first element of this tuple, we would put my_tuple, and inside square brackets we would put 0. Now if this was a list, we can then put the assignment operator and then choose what to assign this element in the list. However, with tuples, if we try to assign this a new value, for example the string hello, you can see we run into a type error, telling us that the tuple object does not support item assignment. This is what we mean by immutable. The elements cannot be changed. However, if the element inside the tuple itself is a mutable data type like a list, i.e. the nested item, then the nested item can be changed. So you can see here we have a list inside of this tuple. So if we access this list, we can put my_tuple, and in square brackets we would put index 5, seeing as it's the 6th element. This will bring back the list. If we now want to change the value 8 to be the value 80, we can then use nested indexing by placing another set of square brackets and then putting the index 2, as 8 is the third element in the nested list. If we assign this to be the value of 80, when we take a look at my_tuple, we can see that the value 8 inside of the mutable list object has been changed to 80. Now let's think about this for a second. Why can we do this? Well, if we think about it, as soon as we access my_tuple and put in index 5 in square brackets, we have returned a list object. So we can now chain list methods to the end of this indexing because we're now working with a list object. So if I wanted to add an element to this mutable list, even though it resides inside of a tuple, we can do so. So if I was to put my_tuple square brackets 5 and then put .append, we can add another item to this list. So let's add the value 100. When we now run my_tuple, you can see that 100 has been appended to the list object which resides inside the tuple. So note here that if we try to change an element inside of a tuple element, we will get a type error, as tuples are immutable objects. Whereas if the tuple itself contains an element which is of a mutable data type like a list, we're able to change the items in that element specifically. Now, if we wanted to change the values of a tuple, the way we can change them is by reassigning values. So here, if I type my tuple, you can see we have a long list which starts with 5 integers. Now, if I were to put my_tuple and then assign this a new tuple which contains 3 strings, so we'll put 1, 2, and 3. We have now changed the items stored inside my_tuple, but this is reassigning a completely new tuple to this variable. So we haven't changed the original object, we've actually assigned it a new tuple. Now a couple of other things we can do. If I type out my tuple, I have 3 elements within it. Now I can use the plus operator to add more elements to it. So if I put my_tuple and then put plus, I can then add 3 new items to our tuple by first providing brackets and then put in strings such as 4, 5, and 6. Now when we use the plus operator to combine two tuples, it's known as concatenation. So what we've actually done here is brought back a new tuple. This won't be stored anywhere unless we assign this to a new variable. So once again, we haven't changed the original tuple, we've simply concatenated another tuple, but then we would need to reassign this to a variable, so let's call it my_tuple_1. And now whenever we access this new variable, we have the 6 elements accordingly. Now another thing we can do is use the star syntax to bring back a new tuple. So for example, if I take the original my_tuple, which has 1, 2 and 3 stored inside of it as strings, if I multiply this by 2, we get the sequence of 1, 2 and 3 twice within our tuple. And if we wanted to, we could assign this to a new variable and then use it later in our code. So remember, tuples themselves are immutable objects. We're unable to change the elements once they've been assigned. However, if there is a nested element inside of the tuple which is of a mutable nature, such as a list, we're able to change the list's elements. For tuples, we can use concatenation to add values to our tuple, but we'd need to reassign or assign this to a variable. And the same with the multiplication, we're able to repeat elements in a tuple, but this brings back a new tuple and we need to reassign or assign this to a variable in order to use it later in our code.